In a convolutional neural network, each convolutional layer has two parameters. The first parameter is the size of the patches extracted from the input. That is, what size filter do we want? Do we want 3 by 3, 5 by 5, 1 by 5, etc. Next parameter is the depth of the output feature map, which is basically how many filters or how many convolutional neurons do we want in that layer. And in Keras, whenever we create a conv2D layer, we can specify these two by defining filters. This is how many filters we want, that is the depth of the output feature map. And the next parameter is the kernel size. Filters are also known as kernels. So this is your first parameter, that is the size of the path. So we can either specify this as a single number, in which case Keras automatically assumes that we are wanting a 3 by 3 or 5 by 5, whatever the number represents. But we can also specify this as an ordered pair where I can go 3 by 1, which means I want a filter of size 3 by 1. Now let's look at the process of convolution. Say we have an input image that looks like this, where this is the width of the image. Our width is here, and we have the height here, and this is the depth. Say the image only has 2 channels right now, 2 channels. Then imagine breaking this image down. Say I take the first piece, first block here, and take it out, and this is my first piece. Similarly, I can take another piece like this out, and this becomes my second piece, and so on. So for each of these pieces, imagine that we have three filters or kernels or convolutional neurons, which perform dot product with these inputs. So each dot product, one filter will give me one value. So this is the first filter, we have second filter and third filter. So for each of these blocks, I will get 3 values because I'm applying 3 filters, and these go out as first one goes here, second one is here, and third one is here. So the output depth is controlled by how many filters I have. And the height and width are controlled by my filter size. So here in this case, if my input is 1, 2, 3, 4, 5 by 5, the output I get is 3 by 3 because the first multiplication with my dot product, these 3 by 3 values squeeze into one value. The next 3 by 3 squeeze into another value, and so on. Now, one question that you may ask is that the height and width of the output feature map may not be same as the input. Why? So the height and width may not be same. The first reason could be that here in this case, our height and width are, let's say, 5 by 5, and our output is 3 by 3. The reason why the output and input do not have the same is because of our kernel size. So if we are extracting using a kernel of size 3 by 3, then if I have a, say, 5 by 5 input, 1, 2, 3, 4, 5, a 5 by 5 input, and if I have a, say, filter size of 3 by 3, then the first multiplication happens with this grid, and what this gives me is I multiply element wise, right? First element with the first, second with the second, third with the third, and then sum them up. This gives me one value. And then I do the same thing for the next grid. So I go from here all the way to here. I multiply, I get another value, right? Same thing for the last possible grid I have, and then I get another value. Next, I scroll down and I look at another 3 by 3 pixel, which is my region over here. I get another value, and similarly, I will get total 3 by 3, that is 9 values. So my input is 5 by 5, but my output will be 3 by 3. Another reason why these two may not be same is how much you want to skip it each time. So right now we are sliding by only one step at a time, but if I slide by 2 or 3 steps at a time, then the output even further becomes smaller.